Good afternoon, class. This is Mrs. Tanga. I'm sorry I can't be there. I am not feeling well, but that should not stop your learning in chemistry. So today we're just going to continue our lesson on the electrons in the atoms. Before I continue, just so you know, you're still expected to write down your notes, so make sure you're still writing your notes. And at the same time, there will be questions embedded in this lesson, so make sure that you watch and you answer those questions. After we're done, you are expected to do your assignment, so make sure we get this done. All right, okay. So last week we talked about electrons in the atoms, so we specifically talked about light. We talked about how light comes in two forms. It comes in the form of a wave, and that's where we looked at the electromagnetic spectrum. And it also comes in the form of a particle. All right, so this is just a brush through. I'm not gonna go through the whole thing. But yeah, so this guy, his name is Max Planck. He found out that when your atom receives or loses energy, it actually produces some type of light. Okay, so he called this small energy that can be gained or lost as a quantum. So whenever a quantum is received or lost, something happens to the atom. So when it gains when it gains energy, I should just say gain energy in that notes, it becomes excited. And then when it loses that energy, it goes back to its unexcited state, or also known as the ground state. So when you're dealing with atoms, whenever it receives an energy, those electrons will go at a higher level. And when it loses it, it goes back to its natural state. And as a result, it produces a photon. So photons are known to be something that would reflect or would emit some type of electromagnetic energy. And that's the reason why when you look at light, it can come in a form of a wave and at the same time in a form of a particle. But I'm not going to go into the nitty-gritty of this because our main goal is to understand what happens to the electrons. However, you need to understand that when the electrons are moving, it can also cause light to be produced. All right, so let's move. If you hear my son in the background, I apologize. All right, so now we're going to be looking at the quantum theory and the atom, okay? So let's look at one individual who contributed a lot in our understanding of the electrons in the atom. All right. So his name is Niels Bohr. We discussed this before. You should at least know that he was the one who proposed that electrons are moving around the nucleus in a circular pattern. And in his model, he actually was able to understand more about why your atoms would emit some type of light whenever it gains or it loses energy. All right, so that's Niels Bohr. So by doing the quantum model, what he's looking at is what happens to your electrons when it gains or loses energy. From his study, he discovered that when you look at the atom, electrons can actually move up their energy state and go back down. And as a result, the energy of the atom on its entirety changes with it. All right. So Bohr stated that when you have an atom, it can only absorb a specific amount of energy. Okay. So when you're looking at the amount of energy it can lose and it can gain, it now changes the state of the atom. So when your atom is not absorbing energy, it is in its ground state. So when an atom is in its ground state, its electrons are in the lowest level. Okay, so it's called the lowest allowable energy level. But when your atom receives energy, those electrons can get excited. So as they become excited, they will move to a higher energy level. All right. So if you look at this picture right here, you can see that when energy is released, when energy is absorbed, those electrons can move up an energy level. But when it releases that energy that it absorbed, it goes back to its ground state. So I need to make sure everybody understands the difference between ground and excited state. So when you're in the ground state, that means there's no extra energy that is being received. When you are excited, or when the atom is excited, what that means is the electrons are absorbing way more energy than what it's supposed to have, and as a result, it goes to a higher energy level. So when you're looking at atoms, when the atom is absorbing and releasing all of this energy, those electrons actually bounces up and down, bounces up and down, up and down, up and down. As a result, it produces what I mentioned earlier. It produces a photon, which in turn we end up seeing as some type of light. All right. So Bohr suggested that the electrons move around the nucleus only in certain allowed circular orbits. All right. So according to him, so if I have an atom right here, okay, let me make sure. Oops, I can't write on that one. Let me write on it. Oops. Okay, it went back on the other side. There we go. So if I have my nucleus, so you have your proton and you have your neutron in the middle. Okay. According to him, or according to his model and his research and experimentation, he discovered that you have a couple of orbits. Okay, I'm trying my best to make a perfect circle, which is obviously not working. Okay, so as you can see, the closer the orbit is to the nucleus, the smaller it is. And as a result, the energy state or the energy level for this particular one, so I'm going to put an X on it, is going to be low. However, the larger the orbit, or the orbit gets farther from the nucleus, such as this one that I'm putting an X on, these ones will have a higher energy state or a higher energy level. So when you're looking at Bohr's model, if I have an electron right here, and that electron receives energy, this electron gets excited and can move to a higher energy level. But as everything, it needs to go back to its stable form, and so it's going to go back down the energy level. So this is what's interesting. And electrons are, as unlike protons and neutrons, your electrons actually can bounce up and down of its energy level depending on the amount of energy that it is absorbing. All right. Now, Bohr assigned those numbers, or the number of orbits, we call them the quantum number, or the letter n. As you can see here, there's about 7 of them. There's a maximum of 7 energy level. As your electron drops, so for example, we have an electron and that electron absorbed energy. Then the electron will move up its energy level. And as it bounces back down to its lowest state to go back to its ground state, that energy released will then end up emitting photons, which will produce some type of light. So it can form ultraviolet, visible, or infrared. The higher or the farther the energy level that the electron is from, and it's going back to its ground state, the type of light emitted is different. So if you look at this picture right here, you can see here, this is infrared. That means if your electron is bouncing from quantum number 7 to quantum number 3, it will release infrared. If it's bouncing from this part going closer to the nucleus, so in this case this is energy level number 2, so you can see it will produce ultraviolet light. And when you have this, as you can see, this is the visible series. That means when your electron is moving back to energy level number 2, it will produce the visible light. All right, that's the reason why if I burn some of my elements or my compounds with a specific element, it will actually emit some type of color. The reason why I see color when you're looking at, fireworks. The reason why you see them in fireworks is because when your fireworks explode, they are gaining that energy level. All right, they're becoming excited, and as the electrons go back to their normal state, the photons are released, and in this case will release some type of light, and that's the reason why we can see colors when you are doing fireworks. Okay, now for each energy level, so again we have 7 maximum energy level. Okay, so this energy level, this 7, is what we call the principal energy level. Okay, so for each energy level, you have a maximum number of electrons that it can handle. So the question is how much? So if we're going to look at the n number, we're going to use this formula. This will tell you the maximum number a quantum or like a principal energy level can handle. At its ground state, obviously, it's not going to be that much, but when it becomes excited, it can handle that much of electrons. All right, so for example, principal energy level 1, that means n is equal to 1. To find out how many electrons it can handle, what I'm going to do is I'm going to go and use this formula, 2n squared. So if I do that, all right, 2, 1 squared. 1 squared is equal to 1, so that's 2 multiplied by 1. That will give you a maximum number of 2 electrons in principal energy level 1. All right, let's keep going. What about principal energy number 2? So that means we're still using the formula 2n2. So that's going to be 2 times 2 to the power of 2. 2 to the power of 2 is 4, so that's 2 multiplied by 4, maximum of 8 electrons. Okay, now let's keep moving. How about n is equal to 3? That will mean 2n is squared, 2, 3 squared. 3 squared is 9, so it's going to be 2 times 9, maximum of 18 electrons. Okay, so as we keep increasing the principal energy level, that means our quantum number increases with it. By using the formula 2n squared, we can predict the number of electrons, the maximum number of electrons that energy level can handle. Okay, so let's try another one. N equals to 4. If you want to use your calculator to do this, then that's fine. 2n squared. So that's 2 times 4 to the power of 2. So 4 squared is 16. So that's 2 times 16, which gives you maximum number of electrons is 32 electrons. Okay, so as we move on from n to 5, n equals to 6, n equal to 7, we can find out the maximum number of electrons it can handle by using the formula 2n squared. All right, now for each of this energy level, for each principal energy level, it actually has subshells, okay, or sublevels. So it's like level within a level, okay? So the quantum number tells you how many subshells or sublevels you have. So for example, if you look at principal energy level 1, that means your quantum number is 1. That principal energy 1 will have 1 sublevel. And then we move to 2, that's 2 sublevels, 3 has 3 sublevels, and 4 has 4 sublevels. What's interesting is once you get to the 4 sublevel, like that's the highest or that's the maximum number of sublevels you can get. So when you get to principal energy level 4 to 7, you will only have a maximum of 4 sublevels. So those sublevels have names, okay? So I'm going to go back to this picture, but let me go in here first. Let me go on this one. So we have 4 sublevels, okay? So we have the S, the P, the D, and the F. All right. So the lowest sublevel you'll have is S. That means I'm going to write this down when I go back to the previous picture. Whenever you have a sublevel present, S will always be there. Okay, so I need you to look at this. So S has 1 orbital, P has 3, 5 has D has 5, and F has 7. We'll go back there in a little bit. All right, so if I'm going back to the picture right here, I can tell. Let me see if can I change the color of this pen. Hold on. Oops. Oh no. Okay. All right. Let me check and see if I can change the color. Okay, that's so we can see. Okay. So for n is equal to 1, I only have one sublevel. And you always have to have the lowest sublevel present first. So in this case, for n is equal to 1, I only have S present, because that's the only sublevel that you can fit in, and in principal energy number 1. When you get to principal energy number 2, you will still have S, but now you also have P. Make sure you write this down. Okay? When you are in principal level number 3, again, you'll have S, you'll also have P, and you'll have sublevel D. Okay? And when we get to sublevel 4 up to sublevel 7, you have a maximum of 4 sublevels. So now it's going to be S, P, D, and F. All right? So as you can see, when I'm in sublevel 1, okay, I'm in principal energy level 1, I have S because that is the lowest energy, the lowest sublevel. As you move up, you can see that you need to have the previous sublevels present before you go up. So if you look at principal energy number 1, S is there, and when you get to 2, S is still there. All right? So these are sublevels. I'm not going to go into the details of this really, not today, but we need to understand this when we get into the next part, which is the electron configuration. All right. Okay, so I'm going to move. So what do we mean by this orbital? So I said, S has 1 orbital, P has 3, D has 5, and F has 7. What exactly does an orbital say or tell you? An orbital is literally just an area, like a predicted area of where you will most likely find an electron. So Werner Heisenberg, he said, it's hard. You cannot find the specific location of an atom. You cannot find the specific location of an atom. But we can predict the area that you will most likely find it. So that's what an orbital is. So when I say that S has 1 orbital, that means the electrons in that lowest level, I have a prediction of where I can find them. I can't pinpoint the specific location, but I can pinpoint the possible area that you can find it in. Each orbital can handle 2 electrons. Okay, it can handle a maximum of 2 electrons. So if you are looking at the S sublevel, the S sublevel can handle a maximum of 2 electrons. If you look at P, it has 3 orbitals, so that's a maximum of 6. D has 5 orbitals, so it has a maximum number of electrons of 10. And F has 7 orbitals, so it can be filled by a maximum of 14 electrons. Okay, so by doing this, we can actually account to the number of electrons that's present. Okay, all right, so if I'm going to apply orbitals and subshells into Bohr's model, that means I can redraw this to at least give you an idea of what we mean. So when you're looking at S, P, D, and F, that also we will talk about this later, but it will also deal with the maximum number of like the energy level. It will also carry on or piggyback on the energy that you have depending on the subshells that you are in. As to what Bohr's model looked like, I will then start with black pen so I can make a difference. So this is your proton and neutron, this is your nucleus. So if our N is equal to 1, okay, so if N is equal to 1, we only have 1 sublevel, which is S, and you can handle 2. That means I can have 2 electrons in there, okay? Now, if I have the second sublevel, which is N is equal to 2, I'm going to use red just so you see the difference, okay? So this is N is equal to 2. Let's remember that N now has 2 sublevels. That's S, which is max of 2, and P, which is max of 6. So that's a total of 8. That means principal level number 2 will have 8 electrons. Okay, so I'm just distributing it just so you can see it. That's the max it can handle. All right, now if we're gonna go to number 3, let's use blue on this one. All right, here we go. All right, N is equal to 3. That means it has 3 sublevels. So N3, so you have S, P, and D. That will be 2, 6, and 10. That gives you 18. So if I'm going to do that, that means I'll have to put 18 electrons here. Okay, that's 4, 7, 8, and 9. Okay, so if while I'm doing this, as you can see, I'm putting them in pairs so I can visualize that I have that amount. All right, and of course, if you get to N is equal to 4, that means now you have 4 sub-levels. Let me use a different color. All right, so now our energy is getting larger, or the amount of energy is increasing because now the orbit is way bigger. So this is N is equal to 4. I'm going to stop with N is equal to 4. So N is equal to 4 means you have 4 sub-levels, which is S, P, D, and F. That means you have 2, you have 6, you have 10, and you have, what's F? 14, okay? So that would give you a maximum of 32. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I'm trying to find a space. 29, 30, and 31. Oops. Oh no. 31 and 32. My pen died, so let me go get another pen. All right, here we go. I think it's 31 and then 32, right? Okay, here we go. There it is. Sorry, I have to get a different pen. Okay, so I think 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So I need 2 more. All right, so 30, sure, why not? 31 and 32. Okay, so as you can see now, you can identify how many electrons are there for each atom principal energy level. Okay, so now let's move on. There are electrons that actually matters, and all electrons matter because it's part of the atom. However, some electrons can participate in a chemical reaction, while some do not. The electrons that do not participate in chemical reactions are called the kernel electrons. Okay, they're usually on the outermost energy level. Valence electrons, on the other hand, are the electrons that are participating in chemical reactions. These ones are found in the highest energy level. So if you're going to create those subshells, like the one that I did just previously with the circle and the dots, the valence electrons would be on the outside. Okay, so what I'm going to do is I'm going to go and use an example. I'm going to use aluminum as an example. Okay, so to figure out, okay, how many electrons do I have to draw? So the first thing I need you to do when you have an element and you're going to write this type of model is you need to first identify the number of protons. Okay, so if you look at the periodic table, if you look at the protons or the number of protons of if you're going to look at the number of protons of aluminum, the proton number is 13. I hope you guys remember how to do this. Okay, so it's going to be 13. Okay, proton number is the same as the atomic number. Okay, atomic number. So this one will be 13. And let's remember that proton number is the same as the electron number at ground state, guys. At ground state. This is not excited. Okay, so this is at ground state. So what that means is the number of electrons would be the same as the proton, which means there will be 13 electrons for aluminum. So how do we do this? How do I write this down? So first thing you need to do is, normally what I would do is I would write the element in the middle just so I know what I'm doing. So if you look at the symbol of aluminum is Al. All right, so this is my nucleus, guys. So what we're going to do is we're going to go and draw out the electrons, like the principal energy level. So to do that, we need to do a little bit of a countdown, okay? So let's look at the first principal energy level. So let's remember n is equal to 1 has a maximum of 2 electrons. So I have 13. So right now I got 1 and I have 2. Okay, so for the first sub-level, if you look right here, for n is equal to 1, I have 2 electrons, but I need 13. Okay, so let's go on energy level number 2. We know that's a maximum of 8, so let's go. All right, so we got 1. Okay, so we already have 2, so that's 3, 4, 5, 6, 7, 8, 9, and 10. Okay, but as you can see, we know that n is equal to 2 has a maximum of 8 electrons. So right now we are at 10 electrons. However, I need 13. So what that means is I need to create a brand new principal energy level of 3. Okay, so remember we're already at 10. So all I need to do is add 3 more. So 1, 2, and 3. So in this case, for this particular, for this particular element, n is equal to 3, I only have 3 electrons. Okay? So I have 13 electrons in this picture. So what that means is any electron that is on the outermost layer is called the valence electron. So this is your outermost layer. So if you look there, I have 3 electrons in there. That means I have 3 valence electrons. Okay? Now, if you're looking for the kernel, all of the electrons other than those 3 on the outside will be your kernel. So that means it's this 2. If you count that, that will give you 10. So this is 10 electrons in total. So that means I have 10 kernel electrons. Okay? So that's how we do this process, and that's how we use this diagram to figure out, okay, where are my electrons? How many electrons do I have that is able to react with something? What is my maximum energy level? All right, so as you can see here, this is how the process looks like on how to write the model. So what I'm going to do is I'm going to go and move on and give you examples just so you know exactly what to do on your assignment. Okay, so here we go. So let's draw Bohr's model for the hydrogen. So if you look at the periodic table, as I asked you earlier, make sure you know your proton number. So if you look at hydrogen, the atomic number is 1. That means the number of electrons I have is also 1. So I have hydrogen here. Because I only have a 1 electron, okay, so write down your first principal level. Then you have 1 electron, so 1. You're done. That's how you write the model for hydrogen, okay? Not really complicated because I only have 1 energy sublevel on that, principal level on that one, okay? How about the next one? Let's go helium. Again, proton number. Look at the periodic table. That will be a 2. Number of electrons is the same as proton number, so that's also a 2. So again, all of this right now are in its ground state, okay? So let's write helium right here. Okay, that's my nucleus. So first level, I have 2 electrons. I know it can handle 2 electrons too, so I'm done. That's it. Okay? All right, let's look at oxygen. Okay, so oxygen, if you look at the periodic table, oxygen, the number of proton is equal to 8. That means I have also 8 electrons. Okay, so O, All right, here we go. That's my nucleus. So let's draw the first of the first principal level. I know I can handle only 2 electrons right here. So 8 minus 2, that means I have 6 more unaccounted for. So let's draw the second principal energy level. And okay, so right now I'm at 2. I need 6 more to make it an 8. So 3, 4, 5, 6, 7, and 8. All right, so that is how we draw Bohr's model of the electrons, incorporating the principal energy level and the electrons that are representative of that element. All right, so for today's assignment, you guys make sure that you submit your notes and also work on the assignment on Blackboard. It's called Bohr's model. So I am going to give you literally the same problems as this one. All right, so make sure that you count, or you put into consideration the count of the electrons and how many electrons each of the principal energy level can handle. All right, so do that work, please. I know I won't see you until next Tuesday, so I expect you guys to work on this and complete the assignment. All right, well, I'll see you guys around school, and I hope you have a great day.